All right, so today we're going to do a little bit of Django review. So Django as a whole is a tool that helps us build full stack applications. So it has a few moving parts. One part of it would be our UI, so our user interface. This is what the user sees and interacts with. So this is going to be our HTML templates, along with our JavaScript static files and our CSS. Static files. Okay, so this is one major part of our full stack application that we're building. We need a user interface. The other part is our data. So I'm actually going to call this data models. So our data models are how the data, our application uses is stored. So what format it's in, what are the relationships between all of our data points, and yeah, so it defines how our data that we're going to use in our site gets stored. Another part to this is our controller. So this is our views.py file, right? So this is logic that is basically a middleman between our UI and our data. So logic that is between UI and models or data, let's call it data. Yeah, so this is basically what our views are. It's just a middleman, and inside here we define certain methods that so some things that these controllers can do is receive requests. So from the front end. Okay, so we're receiving requests from our UI part, from our front end. We are going to be creating, so create, read, or we can call it fetch, so we can grab data, right? So create, well, apparently I misspell things when I'm handwriting too. Create, fetch, update, and delete data. We can call APIs. What else? Do other logic stuff. And then we have to send a response. So this part here, this one has to happen, and this one has to happen. We are always receiving a request from somewhere on the internet. It's always going to be an HTTP request that is coming in. That's why when we're defining all of our functions in our views, we have it automatically take in something called request, right? So we receive a request from either the UI or the browser, which is kind of the UI. So and then we are sending a response back to the sender. And this one can be in the form of an HTTP response, a JSON response, a redirect. So you're going to redirect it to a different page, or a page render. Okay, so the difference between HTTP response and JSON response is that an HTTP response will return either a string or it will return HTML elements. So it's a response in the form of a template or like tags, you know, just actual HTML, or a string. So these are the only two valid types. With JSON response, you will want to use a JSON response when you're returning data. So if our front end is just asking for data, or there's a GET request that is asking for just data, then you will want to return a JSON response, which is just an object of data, pretty much.
And we've never done that, right? We haven't sent back our own JSON responses yet.
I think we might have done it once in passing, but not really, no. So this will come in handy when we are creating our API. So when we're creating our views to return data to our front end. So when we're using React and we want to grab data from our backend, we have to send an API request to the backend asking for whatever data we want. So let's say we have in our database, we have like lists of books, and we send a GET request from our front end, from our React. It could be also from the front end in Django. So it could be from one of the JavaScript files that we're sending a GET request using Axios, right? So we're sending a GET request to our backend, goes into our views grabs the data, and then it sends back a JSON response with all the data that we want to send in.
Oh, I had a quick question.
Uh-huh.
And I don't remember exactly what it was, but is it basically, is it possible to do a JSON response and a redirect at the same time?
I don't believe so.
Okay.
Let me see.
I also want to say no, but I'm not certain either.
So a redirect and JSON response.
So my brain says if you manually redirected them to a page of your choosing, and then on that page you had the script to pull whatever other data you wanted, which would have been the part of the JSON response, I think it might be possible.
Yeah.
But you're really doing that more on the back end side instead of sending both a redirect and the JSON response.
Yeah, I do think so. When we do a page render, we always choose like the template name and then we send in the data. I think you might be able to do that with a redirect as well. But I'm not 100% sure.
Yeah, and actually touching on that, I mean, we use that like HTTP response class that Django has for a redirect response. At the end of the day, I'm sure there's a way using Django's classes in Python to like manually construct an HTTP response message that both has a redirect code in the response header and has some JSON in the body, I think, but I actually don't know.
Yeah. I do think it might be possible, so we can look into it. But in general, so the redirect and the page render here. So redirect, page render, these are going to be specifically when you're using Django front end. So when we go to React, you're probably going to be responding with a JSON response most of the time. Because when you're in your front end and you want data, you're just requesting data, or you're sending, you're sending data or updating or whatever you're doing. So usually a JSON response will happen, or you should make it happen when you make a response from there. Okay, any question on these so far? I know we didn't go too much into depth in these. We'll talk about it in a sec. But yeah, any questions?
Is it possible that when we start doing reviewing some code, we could just see that, like, have a visual of the difference between the HTTP response and the JSON response? I hope that makes sense.
Yeah, definitely.
Okay.
Yeah, we'll do that. Okay, so thinking back to our Django projects, right? We have our templates. Let me just name this templates. Okay, so we have our templates, we have our data models, we have our controller. Another piece of the puzzle that we always use is our URLs, right? So URLs.py. So our URLs handle our routing. So routing is basically when you make a call to a certain URL, what will this call trigger? What will it do? So we are pretty much, we're associating a URL to a function that will handle the request. The request. So when a request goes to a certain URL, because everything, when we put a URL in the browser or whatever it is, that's an HTTP request. So a request. One sec. Okay, so we're associating a request to a certain URL with a function that will handle that request. So that is all the URLs.py is doing. So you're defining if someone in the browser goes to this URL, I want this function to handle that functionality. If you don't define something in your URLs.py, if you go to it in the browser or you try to reroute to it, it won't actually do anything. You won't see any, you'll see the page that, like, page not found. This is not one of the routes that is defined. Any questions on routing? No. Okay. So let's go back to templates a little bit. So templates are, let me just move all of this down. Give us some more space. Okay. So our templates, oh, sorry. Okay. In our templates, we write pretty much just basic HTML, and we can give it CSS classes and our CSS and HTML can connect. The only difference with templates is that Django gives you a little bit of extra functionality, so you can do, so in Django, you can do for loops, if statements, code blocks, and stuff like that. So that's the only difference between regular HTML and the templates. These templates, like we said, are going to be replaced by the React functions that we're working on, or sorry, the React applications. So all of our front end stuff, our JavaScript that handles button clicks, all of that stuff is going to be handled in React. And then whenever we need data, we're gonna make API requests to our backend. Okay. So data models, we have a few different ways of connecting data. So relationships between data. Okay. So the data models are going to define how our application, how the data that our application uses is going to be stored. So we define the shape of the data. We give it attributes. We give those attributes specific data types. So each model / entity. So sometimes people refer to it as an entity of data. Each one has attributes. And each attribute has data types, a data type, and rules around what is allowed in that for that attribute. So for these attributes, you can have validators. Validators are just functions that run against the input that you're trying to put in. So let's say, going back to the bookstore example. So let's say we have an entity called, or a model called book. And this book has a publication date. And let's say you write a validator that checks whether the publication date you're trying to enter into the system is after today's date. So anything after today's date should not be allowed to be a valid publication date because the date hasn't passed. So inside of that validator, you would check if X is greater than today, then you say it's not valid. So I think you have to return false or something like that. And other rules are like uniqueness. I can't think of the other ones, but there are some that have specific, like max length or something like that. So max length. Okay. So
no special characters or whatever.
Yeah, exactly. Okay, so within our models, we can define a few different relationships. So this is back to our one-to-one, one-to-many, many-to-many. Okay. So with one-to-one, it's getting a little busy here. Okay. 1-to-1. So with a 1-to-1, one entity can be attached or related to one other entity. Okay, so entities are each models, right? And each model, we write them as classes in our models. So let's say we have an entity A and an entity B. Okay, so A and B, one of them has to have an attribute. Okay, so for this to connect with this, they can't just connect generally. They have to connect via attribute. So one of them has to have an attribute that connects to the other class or the other model. When there's 1-to-1, you will have the connection either on A's side or B's side. So either A or B will have an attribute. That is of type one to one field. So inside of this 1-to-1 field, you're basically just saying, okay, I'm inside of, let's say I'm inside of entity A, okay, and there's 3 attributes. This attribute will be a connection to B. So maybe this is called B. And there is a 1-to-1 connection because we define that our 1-to-1 field is going to be connected to our second entity. Actually, I don't know if this is helping or if I should just show it in code. I think for models, it might be easier in code. Let me see. Did I miss questions? Touch on the way, foreign keys.
Yeah, that was the one
Return the object.
question.
Yeah.
I love the diagrams personally. Sorry.
Oh, no, thank you. Yeah. So behind the scenes, it attaches to the ID, right? So when you do this field or a foreign key, it attaches this entity to the ID entity, but Django kind of makes it easier. So when you're pulling, when you say A dot B, then it's going to give you the entire object instead of just returning the ID. So even though they're connected by that ID, when you try to call it, it's going to give you the entire object. And that's just their way of trying to make it easier. So if they gave you just the ID that it was connected by, you would have to manually get, okay, class B dot objects dot get the ID that we got from here. Questions about 1-to-1 fields? So this, if you guys remember, it's like the student and locker situation. So if you have a student, you have a locker, this entity will be called locker. Okay. And it would just be connected to the actual locker itself. And you can set a related name on any of the relationships, which gives you access from locker to student. And even if you don't it gets created in the background. So this is just a Django specific thing that happens. Okay. I'm gonna go this way. So that's the one-to-one, one-to-many. So with one-to-many, we have A, and A attaches to B, could attach to another B2, this is B1. Let's just say this is A1. So A can have multiple. So when we're designing these, where would we put our actual foreign key value?
A.
Why would we put it in A?
Because A, actually, I'm not sure.
Okay, so let's think about it a bit. So we want to add a foreign key attribute. Okay, so for the one-to-one, we're adding a one-to-one field attribute on either this side or this, on either A or B. So either attributes, either models could have the one-to-one field, and that relationship would be solid. So you will have a proper one-to-one relationship. So I'm reading the chat. Yeah, so the foreign key will have to go on the many side. So B, the model that's called B is going to be on the side where there's many of them. So that means that we have to put them in here because this will end up being a list, right? So A1, this will have to be, we'll have to accommodate for more than one connection, which in regular databases, in relational databases, is kind of hard to make happen. So this is basically like this. We have a table. So let's say this is ID. This is one-to-many relationship. What was that? The professor and courses, right? Or actually give me a different example. What could be a one-to-many relationship just in the world?
Actors can have many movies.
Okay, yeah.
How about one family owns many cars?
Yeah, that is also valid. Okay, so let's do actor and movie, and then family, and then car. Okay. So ID. So let's just say here we have a bunch of information. So we have actor information, movie information, family, car, whatever. So an actor can have a movie, can have multiple movies. So if we wanted to say movie here, so if we add an attribute in actor where so we can have a movie, we can have at most one, because we can say, okay, I have a movie 0, so I'm gonna say this actor is in movie 0. What happens if the actor is also in movie 1? That means for actor 2, okay, so give me an actor's name. Keanu Reeves, okay. I don't know how to spell his name. Okay. Keanu Reeves. So let's say Keanu Reeves is in, what was that movie about the dog?
John Wick.
Yeah.
The movie about the dog. I love it.
I was literally about to say the same thing. The one about a dog? Is that what the
Glad you guys understood me. Thank you. Okay, so John Wick, and then what's another one? Matrix.
Constantine, soon to be Constantine 2.
Sure.
Bill and Ted.
We're getting Devil in the White City soon.
Oh no. Okay, so we have Keanu Reeves, John Wick. So let's say we have only one spot for lead actor. So movies have many actors. Let's just say that a movie can only have one lead actor for argument's sake. So if we did this, if we have Keanu Reeves and we only have an attribute movie for here, we can only do one movie. We would have to add another movie column to add his other movies, which is not a sustainable model. So that is why we have to remove this attribute, and we'll keep track of the lead actor on these movies. And then we can say the lead actor here is Keanu Reeves. And for Matrix, also Keanu Reeves. Constantine, maybe Keanu Reeves. I don't know. I'm assuming since he's on the poster. But yeah, so that is why we want to put our foreign key on the model that is there's going to be many of, because of this exact reason. So you can't have a list of things in this one field here. So same with the family. So family 1, family 2, we can have an attribute for car. We can say they have a Camry, but what if they get another car? Then you have to add another field called car something. You have to change the name of it, and then whatever Lamborghini. Just imagine those squiggles were Lamborghini. So then you would have to accommodate for another car and another car, and you don't know how many cars there are. So when you're creating your model, you shouldn't have to add infinite amounts of attributes. So to accommodate for this, we don't add it in the family, but on the car, a car can only be owned by one family, let's say. And car 1 is owned by family 1. Car 2 is also owned by family 1. And then car 3 is owned by family 2, or something like that. Questions about this? So in Django, finding all the movie objects where the actor is John Wick. So we would have to do, okay. Like I mentioned earlier, and we've seen this before when we were working with models, every single relationship, so whether we're doing a one-to-one field, a foreign key, which is for one-to-many, or if we're doing a many-to-many field, if you create the attribute on one side, the other side will automatically get like a ghost attribute, pretty much. You didn't define it, but Django makes it on the back end, and that is where the related name comes into play. So usually how these are, so when you're inside your model, let's say we're in the model car, right? And car has, I don't know, name, brand, that's the word. Okay, so let's say there's only a brand and then family. And this family is a foreign key. So foreign key means that there is going to be a connection to another model. That is all it's saying. And this model can be, what is it called? Yes, there is a connection to a model. And if this foreign key becomes unique, that just means that you can only have one family that owns that one car, and that is it. So that becomes a one-to-one field, which you can just use one-to-one field instead of a foreign key. But anyways, foreign key just basically says that in my car, I have a family attribute, which will link to another model. So this one will link to our family model. And I can set a related name. So our related name is cars. So in our family model, we have maybe, I don't know. Okay, the family members also, that's another thing. That's another foreign key that we might have to set. But so in the family, it will make a ghost attribute called cars, because we set cars over here, that will give us access to the list of family members. This happens only in Django. Django, the ORM, I mean, it doesn't happen only in Django, but it happens with the ORM. So the ORM pretty much grabs every single car that has this family. So let's say this family ID is 1. It grabs all the cars where the family ID is 1, and it puts them into a list for you so you can access them more easily. So you can say family 1 dot, I think it's objects.cars or family1.cars dot all. And this will give you access to all the cars that have been attached because of this foreign key. And if you don't set the related name, this will become cars set dot all. Okay. Questions? Did this make this better or worse? Seeing it drawn out. Better? Okay. Who is still having troubles with the foreign key aspect? So Zach, you're asking, can I do movie? So actor 2.movie.all. Yeah, so similar to this, our actor, so since our movie has a lead actor, we can, when we're setting this foreign key, we can give it a related name called lead actor. Or sorry, a related name called movies. That would work. And then you would say actor 2, like whatever alias you gave it. So this is, let's say Keanu Reeves here. So dot movies dot all. And this would compile a list of everything that has a connection to actor 2 inside the movies, inside the movie table.
So that first part of it, actor 2, that's coming from the actor table, right?
Exactly. So this actor, so actor 2 is equal to actor dot I think it's .objects.get, but let's say .get ID2. So, or name equals Keanu Reeves. And then actor 2, you can access the movies that are in there. Yeah. Yeah, and then join statements. Yeah, so it pretty much does its own join. When you're using that intermediate table, it's automatically joining my family, let's say, and whatever it is attached to. So because of these foreign keys, family is attached to car through this attribute. So whenever we're in family, we have an attachment called car. So that list might be empty, but we still are able to make that connection because of this foreign key that we had set. Awesome. Yes, no. Yeah, Louis.
I got a question about the one-to-one connection.
Mhm.
So we in that example, we put the key on the locker.
Your voice is cutting up a little bit. I don't know if it's on my end.
I said so we'll put the foreign key in the locker in this example.
Uh-huh.
Okay,
What about,
that's it.
wait, no, sorry. What about the student in locker?
We will put the foreign key on the locker table or model.
We would put the one-to-one field key or the one-to-one field attribute, because this is a one-to-one field, on either of them. So with one-to-one, it's A or B. So one-to-one, it doesn't matter which one you put the attribute on. The one-to-one field is going to go on one of them, and that will ensure the relationship of one-to-one between them. So one-to-one is basically a foreign key that has a few extra restrictions. And those restrictions are that this pairing has to stay unique. There can only be, so in one-to-one field, it's a foreign key that's saying that you can't have multiple of these, you can only have one. So that's why there's a specific one for it. It's called one-to-one field. For the foreign key, this allows us, it doesn't have too many restrictions, but it allows us to attach one entity with many other entities from it. And this one has to go, so if A and B, so if A is the one side and then B is the many side, you have to add it on the B side. Put attribute on B, on the many side. Because this model here will only have one connection. It will only have one line going from it to an A type model. That is the foreign key. So we put the attribute in here because there's only going to be one line from here. But you see here on the A side, there are two lines going out. There could be many, many lines going out. So you don't put the attribute on this side, you put you don't put the foreign key attribute on this side, you put it on this side, because there can only be one line going out of there.
On the get, can I put one ID or name that you're trying to call, or can you put multiple if you were trying to get a couple different, or would you need to?
Which one was it?
Oh, down there where you had the actor 2, movie 2, like get,
This
like,
one, right?
yeah, could you be like actors you want equals actor.get 1,2 or something. Like if you wanted like
Multiple?
yeah.
I think that could work. It'll return a list of items, but then you can't do this. Because this will only apply to a singular model object. Versus if you're doing get with multiple names coming back, that's going to be a list. And you can loop through that list and then do this. That'll work. But you can't just do it from a list to getting the attributes. Yeah. This is like doing actor.name. So if you have 2 actors in a list, you don't know which one you're accessing. So yeah, you have to specify which one it is. Other questions?
I have a question. Where we set the foreign key for family, so in order to get family 1 in their cars, we have to do family 1 equals family.get by the ID number.
Yeah, so we would have, yes, similar to this, we would have to grab the family by ID, by name, by whatever. So family 1 equals the family object dot objects dot get, and then we specify how we're grabbing the family. So either ID equals something or name equals something, whatever we have in the family model. So whatever the column names are. So if ID equals 1, then this is going to be family 1, and then we can access the cars.
Okay, thank you.
Other questions? Awesome. Okay. I'm gonna need to clean these up afterwards. Okay, so last thing we'll talk about with the models is the many-to-many. Many-to-many. Also, my handwriting seems to have gotten worse throughout this. Okay, so many-to-many means if we have 2 models, model A and a model B, that's not an A, it's not a B, okay. You can have, let's say, this is an instance of it. So A1, A2, and then B1, B2, let's say B3. So this one can have multiple connections. This one can also have multiple connections. Yeah, so basically many-to-many, both sides are allowed to have as many as they want. So you don't have to really worry about all the extra constraints like we do with when we're writing the SQL for it. So with this, you just have to set an attribute with as many-to-many. I think it's many-to-many field on either A or B. So on either model, you can set this many-to-many field. It's similar to the one-to-one, but the many-to-many just allows a many-to-many connection. So on, let's say, multiple actors in multiple movies. So movie, and then actor. This movie can have multiple actors. So we can say actors equals a many-to-many field. And this will reference actors. Actor And then we can also say, we can give it a related name. And this related name can be movies. So let me make it a little bigger. So what this is doing is we can access our movie through our actor, and we can also access our actors through our movie. So let's say we have a movie matrix. So this is of type movie. So matrix dot actors here will give us a list of actors. Will give us many actors. If we take one of these actors, so let's say here, AC equals matrix dot actors. If we say AC at 0, so this is a list, so we're going to take the first one. If we say AC at 0 dot movies, then this will give us a list of all movies this actor is in. So on the back end, this is creating a join table. So if you want, you can, one sec. Okay, so if you want, you can define your own join table when you're making many-to-many relationships. But if the many-to-many relationship is literally just going to be an ID for the actor, an ID for a movie, then you can just set a many-to-many field on one of them. And in the back end, what Django does is create an actor-movie relationship where you can have them repeat. So you can have actor 1 be in movie 2, actor 1 can also be in movie 1, actor 2 can be in movie 2 as well, and actor 2 can be in movie 1. So this is what it does on the back end. So if you're not going to add anything specific to your join table, so you don't want to carry any information about, like, let's say actor, movie, and let's say in every movie an actor gets a rating or a grade or something like that, then you can create your own table. And that would be its own entity. It would be its own model. And that I can show more with code, and it would probably make a little more sense when we see it in code. But with that, we would be creating our own model. Let's say this model is called I don't know, this is a bad name, movie actors. So this is model C. So then inside of model C, we would have actor, we would have a movie, and each of these will have to be, if I'm not mistaken, foreign keys. So foreign keys. And then we have to set the meta information. So yeah, we have the syntax for this, but we have to set this information to be, I think it was looking for unique, right? And then we set actor and movie. So we're saying that we want this actor movie combination to be unique. And then maybe there's a grade or a rating or whatever. Let's say rating. Rating equals whatever it is. So when we're creating our own join table, we have to create 2 foreign keys, one that goes to the actors table, one that goes to the movie table. And then we have to say that we want this combination of actor and movie to be unique, which is what this is doing. Questions? Any questions about like the many-to-many? So there's two ways. You can either, sorry. So if you only want to have a many-to-many relationship without any extra information on that join table, you can just use the many-to-many field on one of the models, either on the movie or on the actor. However, if you want to add additional attributes, then you can create your own model that will contain a reference to the actor and a reference to the movie, and also whatever extra information you want. And then you have to set the uniqueness for those. Questions?
Yeah, so if you want to do a like the actor movie table, you will not use the. I got a question. Sorry if I just interrupted.
No, please go. Yeah.
So if you want to create the actor/movie table like you have there, you don't use the many-to-many attribute. You just use the foreign key attribute.
Yeah. So this new table is acting as the many-to-many relationship. So you can have these foreign keys here, and then inside of movie and inside of actor, you can say that movie now has, so this is C, or actually let's say the actor. So in here, you can say that there is an actor has movies. And these movies are, I think this is many-to-many. But inside of it, so instead of them creating a new table that keeps track like here, you can say through, and you give the table that you have defined. So through this table, through the movie actors table. So this will say that I have a many-to-many relationship with movies, but according to this table, versus it creating it on its own up here. So if you don't want to define your own table, if you don't want to add any additional information, you're just using the many-to-many field without specifying through. So through will define, I have my own join table that I've created, and I would like to say that this many-to-many relationship is happening through this. So this is how you can connect things together. So it's just telling Django that when we want to grab the movies, it will have to go reference this movie actors table and then find for this actor, for Keanu Reeves, right? What are the movies that he has? And it will be attached to this defined table because now we have a rating as well. Did you answer your question?
Yeah, that answered my question. And so for example, I know I see you got the grade tab right there. That will be its own separate table as well, and you will do exactly that.
Oh yeah, I changed
using the through.
Yeah, so if I wanted to add the rating, then I would have to create this new table here. So if I didn't want to add anything and I just wanted the relationship between the two tables, I wouldn't add anything. I would just use the many-to-many field on either the first entity or the second entity. And it automatically creates this join table for me, this very basic join table that connects an actor to a movie. But if I wanted to add a rating, then I would have to create my own table, and I would have to say that my many-to-many relationship is actually going through this table that I created, just so I have some more information. I added rating, maybe I want to add something else, like how much they got paid on that movie or something like that. Good, makes sense, or okay, awesome. Other questions? Okay. One last thing.
Oh, wait, I had one. I'm sorry.
Oh, no.
And it was in the chat. Michael actually asked it, but it's where's the primary key in the mini to mini of that actor movie or movie actor table?
Primary key, there's going to be an ID. So IDs are not really specified, but there is, like, we don't have to explicitly specify them, but it's automatically generated if you don't specify that there's an ID here. So there is always an ID for anything for any entity that you create.
Okay.
And that is always the primary key. If you want something to be primary key, so let's say with my family model, right? I didn't want an ID as my family key. Maybe I have a name or something like that I want to be the primary key. Then when you're defining your model, you specify that my name is going to be a primary key, and that you set after, like, name equals something, you could say primary key as well. So if you say like varchar max length equals this, and then you can say primary key, and that will set that to a primary key. Yeah. We have related name. Do you have to? No. So if you put a related name, you do not access. So if I have a related name on, let's say, where is my related names? Doesn't matter. If I have a related name on car, so car has family attribute, and the related name is, let's say, cars. So you would use it as .cars instead of .car set. So if you, I'll write this down. If you set a related name, you can only access the related list using that name. Else, you will use model name underscore set. So if you do set a related name, model underscore set will not work. It's not a thing that exists. Yeah. Other questions? All right. Let's pause this. If it will work.